Welcome back, everyone. Today we're going to look at some more quadratic equations, and in this video we're going to look at a method called completing the square. So why do we need another method? There's the factoring method, there's the square root method. Why do we need one more? Well, the factoring and square root methods are great for solving quadratic equations, but they do not work in all cases. For example, x squared plus 6x minus 3 equals 0. The factoring method will not work as the polynomial is not factorable. So there's no factors of negative 3 here. They're going to add up to 6. So we can't do that. And then the square root method will not work as well as this polynomial contains a linear term. So remember that this is your quadratic term, that guy. This is your linear term. And that's just our constant, okay? But because of that linear term, that means we can't actually use the square root method. So we can't use factoring, can't use square root, we're stuck. That's where completing the square comes in. Now, to complete the square, we're going to have to review an idea called trinomial squares. A trinomial square is a trinomial that has identical binomial factors. So an example here, x squared plus 4x plus 4 is a trinomial square because the factors are x plus 2 and x plus 2. So we have the same factor written twice. To determine if a trinomial is a trinomial square, you can perform the following test. I have the word test there twice. Step 1. Are the quadratic and constant terms perfect squares? Again, quadratic term, constant term. So are they perfect squares? In this case, it is. It is. And then this next step looks kind of funny. Does b divided by 2 squared equal the c term? So the b value in this quadratic right here would be the 4. So just the 4. So if I go 4 divided by 2 squared, does that equal the c value? Well, 4 divided by 2 is 2, and square that is 4. And you can see the c value is 4. So the final term is that c value. When I'm talking about that, I guess I should bring up, remember the general form of the polynomial, or sorry, this trinomial, ax squared plus bx plus c. Okay, so that's what a trinomial square is. So some more review on trinomial squares. To factor a trinomial square, determine the square root of the first and last terms, that's the quadratic and constant terms. Then take the sign from the middle term, the linear term. So here are 3 examples we can look at. Okay, so first of all, we have to identify if they are trinomial squares. So where do I have room here? I check out my first term. Is it perfect square? Yep, it is. Is the final term, is it a perfect square? Yes, it is. So now I have to see if the b divided by 2 squared calculation works. So remember, b divided by 2 squared. So in this case, it'd be 8 divided by 2 squared. That equals 4 squared, which equals 16. And again, remember, that's got to equal that c term, and it does. So we know it is a trinomial square. So then now we can just write the factors up, which are pretty easy. We take the square root of this first term, x, square root of the last term, 16. Oh, sorry, square root of 16 is 4. And then we take the sign from the middle, so it'd be a plus, and then we just close my bracket and write a 2 there, squared, because it's x plus 4 times x plus 4. And if you're not sure if that's true, then just multiply that out. Let's try this next one. All right, t squared, perfect square. 25 is a perfect square. So let's check out our calculation. Negative 10 divided by 2. So again, it's just negative 10. It's not negative 10t. We just take the constant from that b value. Then I got to square this thing. So that's negative 5 squared, which equals 25. And you can see, yep, 25, that's the c value. So this definitely is a trinomial square. So to factor it, it's going to be t. That's 5. And then I steal the middle term, or the middle sign, so t minus 5 squared. One more. D squared is a perfect square. 49 is a perfect square. Now, if you're wondering why are those perfect squares, because 49 can also be 7 squared. 25 can be 5 squared. 16 can be 4 squared. So those are perfect squares. So my calculation now, so 14 divided by 2 squared equals 7 squared equals 49. Now, you don't actually have to show that calculation when you're doing it yourself if you're ever testing, but that's the thinking you'd have to go through. So this, again, is a perfect square. So then I'm going to get d plus 7 squared. All right, so for the completing the square method, knowing how to work with trinomial squares is essential. All right, so let's begin these completing the square examples. The first thing you're going to do is you're always going to isolate the constant term. And again, that's this term right here. So my first step, x squared plus 6x, and then I'm going to move this guy over. So equals 18. So first step, isolate your constant. I'll just write one word, just isolate. Okay? You know what? I changed my mind. Isolate constant. All right, the next step, once you have this constant isolated, we're going to create a trinomial square. Now, how do we create this trinomial square? Well, we need to, and where I'm creating the trinomial square, everyone, is on this left side. So you can see that there are 2 of 3 terms. So I need a third term to make this into a trinomial square. You can see that the x squared, well, that's a perfect square, so I got to come in with a third term that's a perfect square as well. The way we do that is with that familiar b divided by 2 squared step. So if I take my b value, which would be 6, 6 divided by 2 squared would be 3 squared is 9. That means I should add 9 to both sides. Or sorry, add 9 to my trinomial. When I add something to one side of an equation, you must add that same amount to the other side as well. So I'd have x squared plus 6x. Let's change the color here. Plus 9 equals 18 plus 9. So now over here on the left side, what we've done is we've created a trinomial square. Okay, once you create a trinomial square, your next step is to actually factor your trinomial square. So we just worked on that. The factors for this one would be x plus 3 squared. And then on the right side, we add the constants. Okay, so that's 27. Now, once you get into this form, what actually happens is you just slide into your square root method. Square root method. So completing the square is actually just a method that allows you to turn a quadratic equation, turn it from something that you couldn't use the square root property on or square root method on into something that you can. So now, square root method thinking, take the square root of both sides. I'll get x plus 3, because remember, square root of 4 can be seen like this. And you're really asking yourself what number times itself equals 4. Well, then you can see in this step that 2 times itself equals 4. So same thing here. What we're actually asking ourselves is x squared plus 6x plus 9. Like what, because x plus 3 squared also means that polynomial. What times itself would equal that? Well, we know x plus 3 equals that. So that's why that just turns into x plus 3. And then that would equal plus or minus. You got to remember to put plus or minus in every time. Whenever you bring a square root, whenever you apply a square root or bring it into an equation that wasn't there before, so when you bring it in, you always have to make sure that you account for the both positive and negative answers. So square root 27, it is not a perfect square, but we can at least reduce it. So we're going to look for a perfect square that's a factor of 27. So if you think about that, that's 9. So I can do that over here maybe, so I can show you what I'm thinking. So 27, that's the same as root 9 times root 3, and then we take the square root of the one that we're actually able to. So then that means root 27 reduces to 3 root 3, or simplifies to 3 root 3. Now, with this plus or minus, that means what I would do, and this is, I'm going to show kind of a little bit extra work that you won't have to do in the future, but for this first one, I think I should show it. This means we're going to solve for both cases. So I'm going to have x plus 3 equals negative 3 root 3. And then I'm going to have x plus 3 equals positive 3 root 3. Okay, so you have to solve for both the negative 3 root 3 and the positive. And then now I'll just subtract 3. Reminder that radicals and non-radicals will not combine. So these are unlike terms, so I'm just going to write negative 3 minus 3 root 3. That's the answer there. On the right side, same thing. I have a radical and a non-radical, so they're unlike terms. So I just write them like this, which might feel incomplete to you, but that's absolutely okay. It actually is complete. It just kind of something to get used to. Now, the shortcut for this, if I go from here, when you realize that this term and this term aren't like terms and therefore won't combine, what you can do is you can be lazy or use a lazy notation. I'll just write this out again. So x plus 3 equals plus or minus 3 root 3. And again, what I'm saying here is if you realize that this term and this term are not like terms and therefore they won't be able to combine, you can just leave the plus minus notation there and you can get lazy and write negative 3 plus or minus 3 root 3. And that means the exact same thing as down here. It means both those answers just written in one notation. So feel free to use that as well. Okay, so that's our first completing the square example. Those 4 steps never change. We're going to isolate, create, factor, and then square root method. Okay, so B, like we said, we're going to isolate that constant term first. So I'm going to add 88. Oh, started with green. We'll flip back to blue here. So x squared plus 3x equals 88. Now, as you get better at things, by all means, you can combine steps and things like that, but I won't be doing that because I think that'd look kind of bad when I'm just showing you something. So again, first step, isolate. Our second step, remember we're going to create the trinomial square. And the way we do that is with that b divided by 2 squared idea. So I'm going to take my b value. Oh, and again, I just want to make sure we're understanding. So I'm targeting my left side. I have x squared plus 3x. I'm going to look to add a special third term that's going to create a trinomial square. Now, why do I want a trinomial square in there anyway? Because then I can factor it down to something squared, which will mean I can use the square root method. So that's why I'm actually doing that. If you're wondering why is this trinomial square in there, it's because it's the key to allowing me to use the square root method. Anyway, back to this. So my b value is 3, so 3 divided by 2 squared. So I can't divide that by 2. I'm going to leave it as a fraction. Don't convert that to a decimal, everybody. Leave it there as a fraction, and I'm going to get 9 over 4. Okay, so x squared plus 3x plus 9 over 4 equals 88 plus 9 over 4. Again, with equations, you can do a lot of things to equations as long as you keep everything equal. So if I add something to the left side, I have to make sure I add something to the right side. All right, so now I know for a fact, because I made it, I know this is a trinomial square. Once we have a trinomial square, again, remember, we are going to then factor. And this is putting it in a form that's going to allow us to use that square root method. So that's going to be x plus, that's the next, x plus, and then I need the square root of 9 over 4, which is going to turn back into 3 over 2 squared. And equals, well, this is over 1, so I'll use a different color just to kind of show this. So that should turn into I need common denominator, so I have to times the bottom by 4. If I times the bottom by 4, I have to times the top by 4, then that'll turn to 352. So then 352 plus 9 is going to equal 361. And when you're adding fractions, you just leave the denominator alone, so it's over 4. So now it is in this form that's going to allow me to use the square root method. So on the first line, way up here, I could not use the square root method. It had a linear term, didn't want that. Now I can. So because of the completing the square, because I made this trinomial square, I'm allowed to use the square root method now. So slide back into all that knowledge. Okay, so x plus 3 over 2 equals, again, plus or minus. You need the plus or minus. Why do you need the plus or minus? Anytime you bring the square root idea into an equation, you have to account for both values that might work there, so you need to bring that plus or minus in. So now I need to take the square root of 361 over 4. That actually works out, and it works out to 19 over 4. Okay? So now, again, like we talked about in that previous question, does this term and this term combine? Well, they're both just plain old constants, so yes, they will combine. So, unfortunately, I can't use my lazy notation. I have to use my kind of full notation. I have to solve for both answers. So I'm going to write x plus 3 over 2 equals negative 19 over 4 here. And then on the other side, x plus 3 over 2 equals positive 19 over 4. So now I'll just solve for x. So x equals, that would be negative 22. Now, as I'm writing this, I just realized that I had a little bit of a mistake, and I'm sure you caught it too. My 4, that should have been a 2 down here. So this should be a 2, and this should be a 2. Okay, good thing I caught that. The reason I caught that is when I was looking to add these together, I noticed, hey, those denominators aren't the same. So easy to make those little mistakes. Anyway, so it's going to be negative 22 over 2, which equals negative 11. And then now subtract 3 over 2 here, minus 3 over 2 there. X equals 16 over 2, which is 8. Now, I don't think I used this notation on the other question. That's that solution set, so by all means, you can use that as well. So now I found the solutions to this quadratic equation, which is negative 11 and 8. And remember, in the context of a quadratic function, what we've just done is found the x-intercepts of that parabola. Okay, example C. X squared plus 10x plus 34 equals 0. Okay, so first thing I'm going to do is I'm going to isolate this constant term. Now, why are you isolating that constant term? I write it that way. What I'm really wanting is the quadratic and linear terms by themselves, but it's easier just to think of it if you isolate the constant, the other part just happens. So if you're wondering why I keep saying it that way, so x squared minus 10x equals negative 34. All right, so again, I isolated first. That was my step 1. Now I'm going to look at this step 2, which means I'm going to create that trinomial square. So to create that trinomial square, I take my b value, so negative 10, divide it by 2, and square it. So that equals 100. Oh, sorry. I'm squaring for some reason. That equals negative 5 squared, which is 25. So I'm going to add 25 to both sides. So x squared minus 10x plus 25 equals negative 34 plus 25. Again, I've now created a trinomial square over here. Now I can factor it. And again, why would I create a trinomial square? So I can factor it into something squared, so I can use that square root method. So this is going to be square root of the first term, sine from the middle, square root of the last term, squared equals whatever that equals, which is negative 9. Okay, so I've isolated, I created, I just factored, and then now I'm going to use this square root. All right, let's get back to it. Take the square root of both sides. I get x minus 5 equals, and then hopefully alarm bells went off for you. We can't take the square root of a negative number. So if we can't take the square root of the negative number, means we can't move forward on this, meaning there are no x-intercepts or there is no solution. So my answer for this question would just be the empty set. All right, so that is how a parabola with no x-intercepts would look when you're completing the square. You'll just have a, or I guess it looks like, sorry, whenever you have a square root, it would have a negative radicand, which means I can't move forward on it. Okay, so now here's kind of part 2, or sorry, type 2 for completing the square. you'll notice now my a value isn't 1. In all the previous ones, I just had x squared, but now I have 3x squared. So what we do there, the first thing I'm going to get you guys to do, where's my red? Is we're going to divide the polynomial by a. So whatever your a value is, and again, what am I talking about a? I'm talking about this general trinomial. So the a value here. Now you could say, technically we could say we divide by a every time. It's just that when a is 1, when you divide by 1, nothing changes. So back to this, I'm going to be dividing by a, so I'm dividing everything by 3. Again, you can do a lot of things with equations. You have to, sorry, my voice there. You just have to make sure that you're being equal. So if I divide something by 3, that means I have to divide everything by 3. If I multiply something by 3, I have to multiply everything by 3. Okay, so I then get x squared plus 4x minus 5 over 3 equals 0 still. Once we've done that, you guys, it's the exact same steps as before. So now I'm going to isolate again. And again, you can combine steps once you get better at this. Like often I would combine those first 2 steps. So x squared plus 4x equals positive 5 over 3, because I would end up adding 5 over 3 to both sides to get rid of that. Once I isolate, now I'm going to create the trinomial square. And so my b value, so 4 divided by 2 squared equals 2 squared equals 4. So I'm going to add 4 to both sides. X squared plus 4x plus 4 equals 5 over 3 plus, I'll write it as 4 over 1 because I see it's a fraction. I know I'm going to have to add that. Again, here is my trinomial square that I created. Once I create it, I then factor it. So I'm going to factor now. And I guess I'll say and collect, because I'm going to collect the like terms on the other side. So I'm going to get x plus 2 squared. I square root the first term, square root the last term, sign from the middle, equals, let's get common denominator. So this has to be a 3. So times the bottom by 3, I have to times the top by 3, I'd get 12. So that'd be 17 over 3. And then once I factored, now what I've really done is I've just allowed myself to use that square root method. So now I'm going to use all that knowledge. So square root, square root. Let's go over here, everybody. So I'm going to get x plus 2 equals plus or minus. And then now root 17, sorry, square root of 17 over 3. Now, I'm looking at this, everybody. Whenever I look at something, so first of all, I look at it, is it a perfect square? Can I take the square root? It's not. So I'm going to look to reduce it. Whenever I think I might have some work, I like to do my reducing work somewhere to the side outside my question. I don't like to do it within my question. So I'm just going to go up here with it. And I'm going to have to work sideways because I just don't have, paper like you guys. So root 17 over 3. Reminder, when you're taking the square root of a fraction, you can break it up like that. It's the same thing. Now, can you take the square root of 17? You can't. Can you take the square root of 3? You can't. So it seems like we're stuck. Now, remember from your other rational expression work, radical work, there's something called rationalizing the denominator. We are not allowed, it's just, its form, we can't leave a radical in the bottom of our fraction. So the way we do that is we multiply this number by 1, because 1 doesn't change the look, it will change the look, but it won't change the value. So you're not allowed to change the value of it, so that's important. So we're going to multiply by 1, and the 1 will look however you need it to look. What we'll always do is we make the 1 look like the radical from the bottom. Why do we do that? Well, you'll see here. So that would equal 30 and 21, so that's root 51 over 3 times 3 is 9. And then now you'll see I can take the square root of 9, so it's 3. So the reason we multiply by the matching number there is that it'll always square that radicand, which creates a perfect square, which means we can then take the square root of this new number. So instead of writing root 17 over 3, I'm going to write it as root 51 over 3. Now again, when I'm at this stage, I check out this number, and can I actually combine them? I cannot, so then that means I get to leave it in this lazier form. X equals -2 plus or minus root 51 over 3. Now again, why can't I do that? The reason I won't be able to combine those is that one's a radical, one is not. F. Okay, this is our final example. Thanks for sticking with me this long. I know it's been kind of long, but you know, I can't really speed it up too much. Okay, so step 1, we're going to divide again. Divide by A. Okay, so the reason we're going to divide by A is I want to get that x squared by itself. Or sorry, that's kind of sounds funny. I want my A value to be 1 once I'm done with this. So x squared minus 11 over 2x plus 3 over 2 equals 0. Now I'm going to isolate. So minus 3 over 2 minus 3 over 2, x squared minus 11 over 2x equals -3 over 2. All right, once we isolate, now we're going to create that trinomial square. So this is an interesting one actually. So I'd go -11 over 2 divided by 2 squared. Well, that looks really funny, so I don't like that. I can change then the form of it. All right, and now when you divide using fractions, I guess that's 2 over 1. Remember that we really multiply by that reciprocal. So it turns to that, which is then -11 over, oops, it'd now be positive 11 over 4 because I have multiplied that together. Or no, sorry, I'm so sorry, guys. Oh, that looks like a plus sign. -11 over 4. Now I square it. So it'd be 121 over 16. Sorry about that. So yeah, so now I'm going to bring that in. I was worrying about how much space I have on my screen there. Sorry, guys, I kind of lost my train of thought in my calculation. Anyway, x squared minus 11 over 2x. Now I'm going to add this in. So 121 over 16 equals -3 over 2 plus 121 over 16. Okay, so when you end up dividing by this A, sometimes you just have more fractions, so people will feel it's a tougher question, and the reason they'll feel that is just the fraction work. So if you're not comfortable with fractions, that's going to slow you down here. But hopefully you're comfortable with fractions, and you're not going to find this to be much harder at all. Okay, again, I have my perfect square here. Now that this looks like a funny perfect square because the numbers are kind of big, but same thing, so that's perfect. Sorry, it's x minus, and then the square root of 121 is 11, square root of 16 is 4, and yeah, you've seen that before, right? It's always going to be kind of in that bracket. And that thing is then squared equals, and then now the work over here, I'm going to be kind of lazy here and just write it in again. So I'm multiplying the bottom by 8, so that means I have to multiply the top by 8. Now, reminder, that is -24 because that was a negative fraction. So when I put those together, I would get 97 over 16. Okay, now I've kind of lost room for my steps there, but I factored, I'll put it here, F for factor. Now I'm just going to use my square root to kind of wrap this up. So I think it'd be smart to bring all this over here. Let's just bring it nice and high up there too. So I guess I'll take that square root like I talked about. So then I'd get x minus 11 over 4 equals plus or minus the square root of 97 over 16. Well, that would be root 97. I can't do anything with that. But the square root of 16 is 4. Okay. Now again, let's look at these. Can I combine them? Well, they have like denominators. So you might feel like you can combine them, but because one's a radical and one's not, I actually can't. So I get to use my lazier notation. Plus 11 over 4, plus 11 over 4. So then I'll move that over. So x equals 11 over 4 plus or minus root 97 over 4. I can also write that as an 11 plus or minus root 97 all over 4. And so then I'd be done there, everybody. Either of these work for me, but for lots of, you'll see textbooks or teachers, they like it in this form, which is just a it's just a form thing. That's the way people like it. It's not like it's actually means anything different. It's just that's the way, that's a preferred look by lots and lots of people. So you'll have to talk to your teacher or check your textbook, and to adjust your answers to look like that isn't a huge deal. I can give you a quick example while we're here. So again, we're done this question. But in case you have this kind of thing pop up, like in our last one, let's see here, I had x equals -2 plus or minus root 51 over 3. Well, if you want to write it in this form, if you're asked to write it that way, then we just got to get a common denominator. So I'll put that over 1. So I can multiply this to multiply that by 3, then multiply this by 3 is -6. So then I'd have -6 over 3 plus or minus root 51 over 3. And then I'd get -6 plus or minus root 51 all over 3. Now, this one, if you used your calculator and figured out the decimal version, it would equal what this one equals. It's just a form thing. So that's something you may have to watch depending on your textbook or teacher. Okay, so that's everything, everybody. I have 2 quick summaries for you. One when a equals 1, one when a does not equal 1. And truly they're the same steps like we talked about before. But when a equals 1, we don't have to worry about the division step, but then we isolate, we create, we factor the trinomial square, add the constants, then we solve the remaining quadratic equation using the square root property. When a does not equal 1, we have to add that division step, but then the same steps. Isolate, create, factor, and solve using the square root property. All right, so I hope that was helpful, everybody. If it is, it's great if you leave a comment so I know. If you're needing more help, make sure you get talking to myself or your teacher. Have a great night.